Today we are going to learn about pre-trained model and what is pre-trained model. First, I will introduce to you what is pre-trained model, and we are going to learn about BERT, and then we are going to learn about GPT, and then we will take a look on the code. So for your reference, some slides are taken from the course in Harvard about text analytics. Especially, I took the materials about BERT and GPT. And also some of the contents I took from this book, Foundation Models for Natural Language Processing. And this book focus is about the pre-trained language model integrating with the media. So what is pre-trained model? The word pre-trained. So we have the pre-trained. Pre means we already did something, and then train, we already trained. So pre is already trained model. So with the what pre-trained models, the main idea behind pre-training is to transfer knowledge from an already trained model. So the keyword is trained model. The trained model means we already have a model and we use that model to do something. So we can do something like transferring the knowledge. It comes in many forms. So if you learn from the text representation, we learn about word to fact. Word to fact is one of the pre-trained model, and they call it the pre-trained word embedding. The pre-trained word embedding in word to fact is fixed. So that's why they call it as the fixed embedding matrix. There are other kind of pre-trained model, for example, like ImageNet, PGG, ResNet, and so on. So that kind of model, they have the pre-trained feature extraction layers. So they already define what are the feature extraction, and we can just reuse it. So the final layers will be fine-tuned. So we will learn about fine-tune next week. And there's also another kind of forms, we call it inversion. So in the inversion, it is based on the RNN. So the RNN, as you know, we have an encoder. So we can use the RNN encoder for the sentences. And again, this is fixed model. And it is a pre-train done on the supervised task NLI. So today we are going also to learn what is NLI. There is another kind of pre-train, we call it ELMO. So ELMO, it is a pre-trained model for contextual word embedding. So the word contextual means it is to understand what is the word. But for example, if we want to know about the word mouse, so the word mouse means we have mouse in a computer and we have mouse as an animal. So we can use this contextual word embedding to fine-tune what is we call as the linear layers. So the evolution of the pre-trained models in the early days, they use only embedding. So the embedding, I mentioned to you about the skipgram. I also mentioned to you about CPOW. Do you still remember what this is? CPOW. If you still remember, POW is back of words. CPOW is the continuous back of words. So we call the continuous back of word as one of the embedding. And then after the development of this embedding, in 2014, Huntington developed GloVe. And then after GloVe developed in 2016, there was a development about FastTech, and then Inversend, and then Elmo. So those things are still in the embedding, only embedding. But after those embeddings, there is a new era where BERT appears, and then followed by GPT, and then followed by another kind of pre-trained model. Yeah, if we look at the flow from the timeline, so the first is just the word embedding with various kind of methods. But in sometimes, though, as you learn the transformer, so the transformer changes many things because we have the transformer now. People use that transformer to create a pre-trained model. So from the 2017, you can see there are some development, for example, like using BERT, and then using the pre-train, and they can do the fine-tune. And then in 2020, they have the GPT. And then they developed GPT-3 in 2020. And then there's also another pre-trained model such as DALL-E, Retro, and etc. So the naming convention, as many deep learning models, including the pre-trained, they have some maybe cute names because they use Elmo, Bert, Albert. Maybe if you see the development, there are some words like Roberta, and then Bart, and so on. So they try to use some cute names. So it is to make people easy understand. And if you look at the GPT, so GPT, they have numbers. It is to indicate the development stage. So we have GPT-1, GPT-2, GPT-3, GPT-4. And I have next year there will be GPT-5 and so on. Okay. So actually it refers to the exact combination of models architecture. And then there will be a training objective to pre-train. So what is the training objective? Yeah, it depends on the model. For example, if you use BERT, you can do the mass language model or MLM prediction. And there will be data. So what kind of data that they use for this pre-trained model? So you can see later some data they use the Google Books, or maybe some of the data from Wikipedia. They use it to build the model. So let's learn about one of the pre-trained model, which is BERT. Actually, BERT is always represented by people with this icon. This is a character in the Bart Simpson, and name is similar with the BERT. BERT means bidirectional encoder representations from transformer. So we have an input. So let's say the input is a text. This is going to be so long. And last Tuesday, we learned about the basic with the BERT in Python. The token shows something like CLS. So CLS, as we learned previously, it is about the class. And then we come into the word. And for this word, actually, they are going to do some mass prediction. So you can see this is mass. What is mass? Later we will check more. And then those word will go into the word, and then we go to the neural network, fast forward neural network with the softmax, and then we check what is the possible classes for this text. So using the output of the mass word to predict the word. So we want to know what is the best possible word of this mass. So that is the idea of the word. So let's take a look. The word bidirectional. What does it mean by bidirectional? Bi means it is not one direction, but it is also considered two direction. So bi means there are two directions, forward and backward. The idea is similar with the bidirectional LSTM. It looks in both directions. So we have the forward layer and we have the backward layers. The word encoders and transform. So it means this pretrained model, they just use only the transformer encoders, and there is no decoder. If you still remember the architecture of the transformer. The architecture of transformer, we have encoder and decoder. So BERT use only the encoder. Later on, we will learn about GPT. GPT will use only decoder. So that's the name of the BERT using the encoder, no decoder. And yeah, you can see some of the model in the pre-trained model. We can classify it with the encoder only, decoder only, or encoder decoder. So the variant of BERT, like BERT, Roberta, Albert, Distilbert, T-BERT, Longformer, they use the encoder only. If it is the green color, GPT, GPT-2, XLNet, GPT-3, OPT, Bloom, so they use the decoder only. The blue color indicates that they use the encoder and decoder. But Pegasus, T5, and so on. And the word representations. The word is the bidirectional encoder representation from transformer. It is a language model that builds rich representation. What does it mean by rich representation? BERT is a type of the word embedding model, and we can classify it something like this one. If the context is independent, so if we do not consider any context, then you can use the common embedding, such as word to fact, glove, plus text. But if you need to look at the dependency of the word, or if you need to do the context dependent, then we can use the RNN base, or we can use the transform base. So the RNN base, we can look at the Elmo, how they are the variants of the RNN. For the transformer base, we have the BERT, XLM, Roberta, Albert. So the representation here is richer than the other kind of methods in the word embedding. So that's why they call it as the rich representations. So at the formal definition, we call BERT as a pre-trained model for contextual word embedding. So if you look at this one, it is the contextual dependent. That's why we call it, this is the contextual word embedding. Originally, BERT has been used for some pre-training tasks. There are two pre-training tasks. The first is MAS-LM. So LM is the language model. Okay. And we can also check the next sentence prediction. For the BERT, the original BERT, they use the training data set, such as the book corpus. So I mentioned to you the Google book corpus. If you go to the Google book, so you can see there are many books, and they use all the text on those Google books. So the word is about like 800 million words. And also they use the Wikipedia English. So in the Wikipedia, there are 2,500 million words. So they use those data set to make the BERT as a pre-trained model. So the training settings, so the billion word corpus was not used to avoid using shuffled sentence in training. So the training is used with long contiguous context. So if the word very long, so they try to indicate whether there are some context dependency or not. So if you look at the BERT, I mentioned to you that BERT has been used. It is initially proposed for the MAS language model. What does it mean by MAS language model? So I took this picture from this site. Actually, this is a good picture, but the brightness is not that high. So let's see if you have this word. So I have this text. Let's stick to something improvisation in this skit. So this text is the input, and then when we want to input into the BERT, we do the masking. What is masking? Masking means you hide something. So if I have the word, let's stick to improvisation in this skit. So if we want to mask this word, then it means we remove the word and we put mask. So we put mask here. And we can just write mask. And we input this text into the BERT. So the BERT will make the embedding, and using the feed-forward neural network with the softmax, at the end, it can do the prediction. What is the possible classes? The possible classes means the possible word for Christmas. And it shows in the all English words. All English words means if there are 100,000 words, then they will show the 100,000 words. And the biggest probability or the biggest score will be selected as the proper word for this mass. So because this is the highest one, let's say 10% is the highest, then this text is the most proper word for this sentence. The other kind of task for the BERT is sentence prediction. The sentence prediction means there are two sentences that are fed in at a time. So two sentences. For example, in this case, the man blah 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 to the store. Maybe the text is too small. The man blah 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 to the store. Dot. So after the dot, we have SEP. Okay, what is SEP? On Tuesday, we learn about the verb. The SEP means the separator. Every sentence will finish by dot, and then it will continue with a new sentence. So the new sentence, in this case, penguin, and then we have some thing that we don't know, which use must, are flightless birds. And then we have another set. Okay. So if we have another set, it means it is another separator, and we can continue to another sentence. So we have two sentences, and we want to know whether these two sentences are truly follow the first one. The first word is about the man. Man means human. And okay, we have the context. It is about storm. But the second sentence is about penguin. And it mentioned about birds. So as a human, we know that those two sentences are not correlated. It is not truly follows the first one. And we input this into the BERT, and then BERT will use the neural network and the softmax to find the probability whether is next or not next. Is next means the first sentence can follow the second sentence. Not next means the first sentence is not truly follow the second sentence. Because this context is totally different, that's why the probability not next is high. So in the BERT, actually, yeah, the structure, as you know, with the encoding, we already done with the encoder in the transformer. We know that the input is something like this one, and then we can fit into the embedding. So the embedding, there are three embeddings. If you still remember, we have the token embedding, we have the segment embedding, and then we have the position embedding. Okay. So last section, we learned about the position embedding. Position embedding means we want to know whether the location of a particular word can be indicated by some formula. So the word, for example, like this one, CLS. So we call this is the class. My dog is, and then we have the mass. something that is hidden. And then we have separator. Means this is dot or this is the ending of the first sentence. He likes playing. So this is the ending. For example, he likes playing, but this is only to embed into the word play. And then we have another separator. For every of this word, we will go to the token embedding. The token embedding means how we can represent this word into an embedding. How to represent this word into an embedding. How to represent this word into an embedding. And after we know this embedding for each token, next we will do the segment embedding. The segment embedding means I know that this belongs to the first sentence, and I know that this belongs to the second sentence because of the separator. And then we want to check the position embedding. The position embedding means I would like to know where is the position of this word, CLS. Because the class or the CLS will correspond to the beginning of the sentence. So usually, yeah, this embedding will be just one. And then we will have X2, which is the position of this word, X3, which is the position of this word, and so on. So the embedding, the total embedding will be the XCLS plus XA plus X1. So this embedding will go to the encoding layer as the transformer that we learned last time. So every of this one will be combined or will be concatenated, and then we will go to the next layer. So this is the sequence of embeddings in verbs. The result of using verb has been performed by one research. You can take a look on this paper. So in this paper, they try to perform verb in comparison with other system. So the other system is, for example, the OpenAI. At the time, there's one OpenAI SOTA. Do you know SOTA? We call it SOTA as the state of the art. State of the art means the current method, the latest method, the new method. So if now is 2024, then we want to know the new method until 2024. So we call that is a SOTA. And then the verb also perform in comparison to the by LSTM. As I mentioned to you, by LSTM is the by directional LSTM. So there is ELMO, which is the context embedding factor, and we also put the attention. And they also try to compare with the OpenAI GPT. So this is the result. So they have the score, and this score has been performed in the glue test result. I think last time I also mentioned there is one site that has been used to compare those results. Whenever researchers come up with a new method, then usually they will use this glue benchmark. So there are some criteria. We call it the MNLI, QQP, QNLI, SST, COLA, STS, MRPC, RT. And the numbers will be shown here. And the numbers, the higher number is the better. So you can see there are two kind of bird. The first is the bird with the base, and the second one is the bird with large. The bird with large means this is the bird with larger model. And bird with larger model show the biggest score compared to the other system, and in terms of those tasks, we call it the tasks. So what are they? So we can take a look on the performance comparison on those tasks. MNLI. We call it MNLI as the multi-genre natural language inference. If you look at the table, you can see M and MM. Okay, so what is M? What is MM? M means match. So if it is match, then we measure what is the score. MM means mismatch. If it is mismatch, then we also compute the score. So the MNLI is a large-scale classification task. In this task, we have given a pair of the sentence. So the goal is to identify whether the second sentence is entailment, contradiction, or neutral. So this is the classification in the MNLI. QQP. QQP means the Quora question pairs. So in this data set, the goal is to determine whether two questions are semantically equal. And then we also have the other task, which is question NLI. So the word NLI is same like this one. NLI, natural language inference. And now we have questions. If this MNLI, it is just to check the first sentence, whether it is connected to the second sentence. But question NLI, in this task, the model needs to determine whether the second sentence is the answer to the question asked to the first sentence. So it means I have sentence 1 and I want to check the answer. So the answer, whether it is correct or not. So if it is correct, the score will be high. If it is not correct, the score will be low. So this is some tasks that you can do if you are doing your project with chatbot. So the question NLI is a good task for this chatbot. Next, we have another task which is using the SST. SST means the Stanford Sentiment Tree Bank. So this Stanford Sentiment Tree Bank is a binary sentence classification task consisting of sentences extracted from movie reviews with annotation of their sentiment. So we have the sentiment about the emotion of the movie. So BERT can generate the state-of-the-art results on SST2. So there is the collection of data in the SST. And then there is also another task which is called COLA. COLA means Corpus of Linguistic Acceptability. It is binary classification task, and the goal is to predict whether an English sentence that is provided is linguistically acceptable or not. So if you have an English word like this one. So you can see whether it is acceptable or not. It is grammatically correct or not. So there are the data collection in this column. There is also another task, we call it STSB. This is the semantic textual similarity benchmark. So we want to know how similar two pieces of text. Microsoft also developed a corpus, they call it as the MSR, or the Microsoft Research Paraphrase Corpus. So it is the dataset from newswire articles. And each pair is labeled if it is a paraphrase or not by human annotators. So every news or every article is labeled, whether they are copy and paste or not. So that's why you can see some tools can understand whether you use ChatGPT or not. Because if you use ChatGPT, then it is only a paraphrase from the original text. RTE means the recognizing textual entanglement. The recognizing textual entanglement means we have a directional relation between text fragments. So the relation holds whenever the truth of one text fragment follows from another text. So the idea of this textual entanglement is similar with the MNLI. So it means we have the sentence one, and then we want to know whether this text fragment follow with the sentence one. But usually in the sentence, we have a fragment. In one sentence, we have fragment. So they want to know whether this fragment follows with this fragment. This fragment follow with this fragment. So they perform those comparison, and you can see this is the MNLI, this is the QQP, QNLI, SST, COLA, STS, MRPC, and RP. And then for all the tasks, BERT shows the highest performance. And when they calculate the average of BERT is the highest among the other system. So that's why people believe that BERT is very useful for the text analytics, for the tasks such as the mass prediction or mass language model, and also the next sentence prediction. Okay. Some application of the BERT, we can use it for the text classification. The text classification, for example, we can do for the sentiment analysis. In the sentiment analysis, let's say I have the input. The first input is CLS, which is referring to the class. And then there is what? The steak was good and tasty. So we just input this into the BERT encoder blocks. After we have the output, so we put this one into the neural network, and we can classify, okay, this is positive. The other kind of application, we can call it text entanglement. The text entanglement means I want to see the connection between one word and another word. So, for example, I have the word it rains. Separator. Separator means, it is finished, done. So this is another sentence. The sun shines. If you look at this one, it rains, the sun shines. Of course, it is not correlated. When we input this into BERT, then BERT can give a result. It is contradiction. So this sentence and this sentence is contradictory. This is the text pair classification. We can also use word as the text annotation. The text annotation, if you still remember the name entity recognition, NER. We can indicate, for example, we have the word CLS, it is the class. Joe Biden went to New York. So when we input this one into BERT encoder blocks, we can indicate or we can annotate that the first word indicate person. The second word indicates person. The next word, okay, this is just an object that represent a word for verb. And then we have a place, New York, or it is indicating a location. Then we can have this one. And we can also use verb to check the span prediction. So span prediction is a kind of question and answer. Let's say I have this word. Maybe the word is something blah blah blah. Who detected America? And then we have a separator. And then there is a word Columbus bricks. So we can input into the BERT encoder blocks, and then for every input, yeah, they can check that this may indicate the starting of a new sentence, and this is the ending of the new sentence, because this indicates an answer of the previous sentence. So in the BERT, actually, there are some extension that you can take a look. What I mentioned to you is the original BERT, but it has been extended, it has been added more by, for example, Albert. Albert is a light BERT. Light means it is lighter, or the weight is less, but the performance is similar to BERT. Roberta, a robustly optimized BERT. Distill BERT. So it is a small BERT, so similar to light BERT, but it is smaller. Electra. It is a pre-training text encoders as discriminators, not generators. And long format. So for this for the long document transformer. So those kind of the variants of BERT. Okay, I will explain the Google Colab maybe on next time. Okay, let's have a break. I will continue about the GPT after the break.